Welcome to my primary maths and SATs help videos. This video is all about equivalent fractions. We'll start by looking at what an equivalent fraction actually is. Then we'll look at how to find equivalent fractions where we have to choose the calculation. Then how to find missing fractions in sequences. And finally how to simplify fractions. And you may find it useful if fractions are new to you to look at my video on an introduction to fractions. So what is an equivalent fraction? Well, the word equivalent means the same. So here we've got a lovely fruit pie. I'm going to represent it using circles. If we were to cut that in half, we would have two equal pieces, and that's represented by the denominator. And I'm interested in the shaded part, so one of those, and that's represented by the one numerator. If I take the same pie and cut it into 4 equal pieces, in other words, quarters, I can see that 2 quarters, if you look at the shaded areas, is exactly the same as 1/2. I could then take the same pie, but this time cut it into 8ths. That's 8 equal pieces. Well, looking at the shaded area, 4/8 is exactly the same size and shape as 2 quarters and 1/2. I might then want to cut the same pie up into 16 equal pieces. If I was to eat 8/16, that's the same as eating 4/8, 2 quarters, or a half of the pie. So all of those 4 fractions are equivalent. They mean the same thing, but they have just different numerators and denominators. I might then want to eat 3 quarters of that pie. That would be the same as eating 6/8 of it if I cut it up into 8ths, or 12/16. And you can see quite clearly again from the shaded areas that those are equivalent, they mean the same thing. So one task that you might be given with equivalent fractions is this one, where you're given a fraction and asked to find an equivalent for it. But before we start, we need to understand certain rules with this. The first one being that when we're working with equivalent fractions, we are only allowed to multiply or divide, never add or subtract. Also, if we're given a fraction and asked to find an equivalent and we haven't been given any other information, we can decide whether we multiply or divide it, and also what we multiply or divide it by. The only thing we have to remember is that whatever we do to the top, to the numerator, we have to do to the denominator. And one more tip, avoid dividing if you can, and only divide if the answer is a whole number. What you don't want is decimal numbers on fractions. So if we start with the first one, we've got 3/5. So we can decide what we do with this. I'm going to suggest that we multiply it, and I'm going to start with the numerator and suggest that we could multiply that by 2. I've chosen that. So then we say 3 times 2 is 6. So another thing that's really important with equivalent fractions is we read from left to right or right to left, never up and down. So we're reading across the numerators here, and now we're going to read across the denominators. So I've multiplied the numerator by 2. The rule is whatever we do to the top, we have to do to the bottom. So now I'm going to multiply the 5 by 2, and that gives me 10. So that means that 3/5 is equivalent to 6/10. So using that same method, let's have a look at the next one. So we've got 4/7 and we've been asked to find an equivalent for it. This time I'm going to start with the denominator. It really doesn't matter as long as we do the same to the top as we do to the bottom. So now I've chosen to multiply the denominator by 3. So 7 times 3 is 21. I simply do exactly the same to the numerator. So I say 4 times 3 is 12. So again, reading across from side to side. So 12/21 is an equivalent fraction for 4/7. Now let's move on to the next one. So we've got 28/36. Now we've been asked to find an equivalent fraction to the left of this fraction, which suggests that we're going to have to divide it, because with equivalence, usually you move to the right when you multiply and to the left when you divide. This is a little bit more tricky because we've got to make sure that we have whole number answers. So what we have to do this time is we have to find a common factor. In other words, one number that both of those numbers can be divided by to give a whole number answer. Now I've recognised that they are even numbers. We could therefore divide both by 2, but I've chosen to go for a higher factor because I can also recognise, using my times tables knowledge, that both of those numbers can be divided by or are divisible by 4. So if we take 28 and divide it by 4, the answer is 7. So that gives me the numerator of the equivalent fraction. I'm now going to do the same to the denominator. 36 divided by 4 is 9. So I've found an equivalent fraction. 7/9 is equivalent and means the same as 28/36. Let's do the same with the next one. So here we've got 7/42. Again, I'm going to use my times tables knowledge here because I can recognise that those are both multiples of 7 and therefore can be divided by 7. So let's do that this time, starting with the denominator. 42 divided by 7 will give me the denominator of the equivalent fraction, which is 6. I then need to do the same to the top. 7 divided by 7 is 1. So 1/6 is equivalent to 7/42. So if we look at our pie slide again, if we think of just the numbers involved, to get from 1/2 to 2/4, we've simply multiplied the top and the bottom by 2. And then to get from 2/4 to 4/8, we've also multiplied those by 2. And then again to get from 4/8 to 8/16. So we could have found those equivalent fractions even without the diagrams showing the shaded areas, but we can see that it works. Also, I haven't shown it here, but we could have started with the 8/16 and divided each time, gone from right to left. If we'd have divided 8/16 by 2, we would have got 4/8, and then divided those by 2, we'd have got 2/4, and so on. And then if we just look at the last 3, we've done exactly the same here. Each one, we've multiplied both the top and the bottom by 2. So now I want to show you a slightly different chain of equivalent fractions. On the previous one, we could jump from one to the other in the sequence. This is different. So here we've got 3/8. If we multiply the numerator and the denominator by 2, we get an equivalent fraction of 6/16. If we then start with the 3/8 again and multiply by 3, we get 9/24. If we multiply by 4, we get 12/32. And finally by 5, we get 15/40. Now we could have gone the other way and divided. But the point here is, as I say, apart from the first 2 fractions in the chain, we can't jump from one to the other. You can't multiply a 6 to change it into a 9, or a 16 multiplied by something to create the 24 in the second and third fractions. So what we do there, when we have a chain of equivalent fractions like that, we have to use our times tables knowledge. So if we look at the numerators, those are all multiples of 3, and all of the denominators are multiples of 4. And this information will help us with the next slide. So here's a task where we've been asked to find missing equivalent fractions in a sequence. So the first thing we need to do is to look at 2 fractions next to each other that we've been given and ask ourselves, have we multiplied one to change it into another? You could also use the division as well, but multiplication is always easier. So have we multiplied the 15, looking at the numerators, to change that into a 20? It's not possible. So that's not what's happening in this sequence here. So when that happens, this is exactly where we need to look for patterns across the numerators and across the denominators. So if we stick with the numerators along the top sequence, hopefully we can see that those numbers are all multiples of 5. So if we start with the 5/9, what have I done to the 5 to change it into the 15, which is in the third fraction? I've multiplied by 3. Then what have I done to the 5 to change it into the 20, which is the fourth one in the sequence? I've multiplied it by 4. Therefore, to get the first missing fraction, I'm going to need to multiply the 5 by 2, which gives me 10. And I simply have to do the same to the denominator. So 9 times 2 is 18. And because we know what the pattern is now, we can quickly fill in the second fraction in the sequence that's missing, because it's going to be the first fraction multiplied by 5. So 5 times 5 is 25, and then 9 times 5 is 45. Then if we look at the bottom sequence again, first thing to do is to look and see, have we done something to one fraction that we've been given to change it into the next one in the sequence? So if we look at the 14/16 and the 21/24, have I multiplied 14 to change it into a 21? No, I haven't. So again, that's not what the pattern is. So again, if we look at the patterns between the numerators and then the patterns between the denominators, hopefully we'll see what's going on. So if we again focus on the numerators, hopefully we can see that those are all multiples of 7. So if I think about that, I can see that the 14, if it's a multiple of 7, it's 2 lots of 7. So to find the fraction before it, I'm going to have to divide by 2. So 14 divided by 2 will give me the 7. And then I simply have to do the same to the 16, which gives me 8. So now I'm going to start working from left to right because it's always easier to multiply. I can see that the pattern is multiply the first fraction by 2 to get the second one, then by 3 to get the third one, and then by 4 to get the fourth one, which is the missing one. So 7 times 4 gives me 28. 8 times 4 gives me 32. Sometimes you're asked to find missing equivalent fractions that look like this, where you're given one fraction with all the information, so both the numerator and the denominator, and then an equivalent fraction that has one of those things missing. So this is the method. You start from the fraction where you have all the information. So if we look at the first one, that's our 4/9. Then you look across from one fraction to the other, reading, as we've mentioned before, across the numerators and across the denominators. So where have you got all the information now reading across from one to the other? In this one, we've been given both the numerators. So that's what's going to help us to know how we're going to find the missing denominator. Because what I then do is say, well, what have I done to the 4 to change it into the 20 that I've been given? Remembering, of course, that we're only allowed to multiply or divide. The answer is I've multiplied it by 5. So once I know that, I simply have to do the same to the denominator. So 9 times 5 is 45. If we look at the second example, we've got a similar pattern here. We start from the fraction where we have all the information. We can see that again, we've been given both the numerators. So what have I done to the 15 to change it into 75? This time I've multiplied by 3. So I simply do the same to the 20. 20 multiplied by 3 gives me 60. If I look now at the third one, again, the first fraction is where we have all the information. But this time, if we're reading across from one to the other, we have all the information in the denominators field. So we're going to use that to help us to find the missing numerator. So what have I done to the 14 to change it into 28? I've multiplied by 2. So to find the missing numerator, I do 3 multiplied by 2, which gives me 6. Looking now at the second row, we've got something over 7 equals 12/14. This time, the fraction where we have all the information is second, so we have to start from there. Then if we look from one to the other, we can see that we have all the information in the denominators field. So now I have to say to myself, what have I done to the 14 to change it into a 7? I've divided by 2. So to find the missing numerator, I simply do 12 divided by 2, which gives me 6. We look at the next one. Again, we've got all the information in the second fraction, so I'm going to start there. This time, reading across from one to the other, I've got all the information in the numerators field. So here I say to myself, what have I done to 15 to change it into a 5? I've divided by 3. So I simply do 27 divided by 3 to give me the missing denominator, which is 9. And then the last one, once again, we've been given all the information in the second fraction, so I'm going to start there. And now I've got, reading across from 1 to the equivalent, I've got all the information in the denominators field, so that's where I'm going to work. First of all, what have I done to 32 to change it into 16? I've divided by 2, so I simply have to do the same to the top. 16 above the 32 divided by 2 gives me 8. Here we have exactly the same thing, but this time with 3 fractions in each sequence. So what we do, just as before, is we start with the fraction where we have all the information. So if we look at the first one, that's our 8/12. So we've got the numerator and the denominator. Now I'm going to see if I can find the missing denominator in the third fraction of the sequence. So to do that, start with my 8/12. I then read across from that to the right-hand one. Where have I got all the information there? Well, I've got both the numerators. So then I say to myself, what have I done to the 8 to change it into a 24? I've multiplied by 3. So I simply have to do the same to the 12. 12 multiplied by 3 gives me 36. Now I want to find the missing numerator in the first fraction in that sequence. So I start with my 8/12 again, and then I read across from that to the one on the left, and I can see that all the information this time is in the denominators field. I've got the 12 and I've got a 6. So I say to myself, what have I done to the 12 to change it into a 6? I divided it by 2. So to find the missing numerator, I take the 8, I divide that by 2, and the answer is 4. Looking at the second example, once again, all the information is in the middle fraction. I'm going to see if I can find the missing numerator of this third one. So I start looking across from the 14/35, I read across the numerators and the denominators. Where have I got all the information there? Well, I've got both the denominators this time. So what have I done to 35 to change it into 140? I've multiplied by 4. So to find the missing numerator in the third fraction, I simply do the same to the 14, and the answer is 56. Now I want to find the missing denominator in the first fraction in that sequence. So again, I start from the 14/35. I read across from that to the left, and I can see that I've been given both the numerators. So what have I done to the 14 to change it into a 2? I've divided by 7. So I simply do the same to the 35. 35 divided by 7 gives me 5. And there's my missing fraction. Another thing that you might be asked to do is to write fractions in their simplest form, and this involves equivalent fractions too, because simplifying fractions means finding an equivalent fraction but with the smallest possible numerator and denominator, and that of course means that we have to divide. So if we look at the first example, we've got 8/12. So the first thing I'm going to do is look at those numbers, and I notice that they're both even numbers, because even numbers always end with a 0, 2, 4, 6 or 8, and therefore they're multiples of 2 and can be divided by 2. So that's always a good thing to look out for first. So if we do that now, we get the answer 4, 6. But I know that that's not that fraction in its simplest form, because 4 and 6 are also multiples of 2 and therefore can be divided by 2. So there's another step. And that is the final answer, because there's no way that we can simplify 2/3 any further. Now, ideally, we try to do this in one step if we can. And the way we do this is we look for the highest common factor, the highest number that we can divide both the top and the bottom by. And in this case, these two numbers, 8 and 12, are also multiples of 4 and therefore can be divided by 4. And there we have the same answer, but just in one step. So that's the best thing to try to do. It makes it quicker. And if you need any more information on factors or multiples, please do have a look at my video on these. So let's look at another example. So again, I'm looking to see, are those even numbers? This time they're not both even numbers, but I do notice that they end with 5 and 0, and that means that they're definitely multiples of 5. So that's another thing to look out for. So if I divide them both by 5, I get 9/16, and I know that I can't reduce that any further. I can't simplify that any further, because 9 and 16 don't have any common factors. Here we've got 36/81. They're not both even numbers and they're not multiples of 5, so I can't divide by 2 or 5. So now I'm going to look for something else. This is where my times tables knowledge comes in handy again. I do notice that they are both multiples of 9 and therefore can be divided by 9. And there's my final answer. That is 36/81 simplified down to its smallest form. And one more example. This time we got 28/42. Well, they're both even numbers, so I could divide them by 2, but I'm going to look for a higher common factor. So I notice that they're actually both multiples of 7 and therefore can be divided by 7. And that would give us 4, 6. But now I notice that 4 and 6 are even numbers, so that's not the fraction in its simplest form. I need to reduce it further. And that means dividing by 2 again. And there's my final answer. So here are some other types of questions that we might be asked involving equivalent fractions. Number 1, represent this fraction as 30ths. If we remember, we get the name of the fraction from the denominator. So if we're talking 30ths, that means we need to change 5, 6 into a fraction with 30 as the denominator. So just as before, we start from the fraction with all the information, which is the 5, 6, and we read across. And in this case, we've got all the information in the denominators field. So we say, what have we done to the 6 to change it into 30? We've multiplied it by 5, so we do exactly the same to the numerator, and there's our answer. Number 2, which two of these fractions are equivalent? Well, what we have to do here is choose either the numerators or the denominators. Focus on one first and read across. Can we multiply or divide one of those to make one of the others? When we've found one that works, we then need to check that we can do the same to the denominator and use times tables knowledge to help. So if we start with the 2/3 and read across the numerators, I could multiply the 2 by 3 to make 6. I could multiply it by 5 to make 10. And I could multiply it by 8 to make 16. So I've got 3 possibilities there that I could link the 2/3 to. So let's have a look. If I choose to see if I can change it into 6/10, can I multiply 3 by 3 to make 10? No, I can't. Could I multiply 3 by 5 to make 15? Yes, I can. And actually, I don't need to do any more because I've already identified that 10/15 and 2/3 are equivalent, because if I multiply 2 by 5, that gives me the 10. And then if I multiply the 3 by 5, that gives me the 15. So I've straight away identified the two matching fractions. Here's another type of question. Complete these fractions so that they are equivalent to 3/5. So this is what I'm going to do. If I start with the 12 somethings, I can see that I've created the 12 by multiplying the 3 by 4. So all I have to do is to multiply the 5 denominator by 4, and that will give me the equivalent fraction. Now let's looking at the tenths. I need now to find the numerator, but I've got both the denominators. I've got a 5 and I've got a 10. So I've multiplied the 5 by 2 to get the 10 denominator. So if I take the 3 from the 3/5 and multiply the 3 by 2, that's going to give me the missing numerator, which is 6. And then the final one, I've got 15. So again, I've got the denominator information. So what have I done to the 5 of the 3/5 to change it into 15? I've multiplied it by 3. So then if I take the 3, the numerator from the 3/5, and multiply that 3 by 3, that gives me the missing numerator, and that's the answer. So here's a quick summary of the main steps that we need to take when we're working with equivalent fractions. First of all, always work from the fraction which has all the information, in other words, both numerator and denominator. Remember to read from side to side across the numerators and denominators, not up and down. Always do the same to the top as we do to the bottom. When we're finding fractions to the right, we need to multiply. When we're finding fractions to the left, we need to divide. But if we have the choice, always multiply. And if you have to divide, only do that if the answer is a whole number and not a decimal. But of course, if you're asked to simplify a fraction, you will have to divide. So in that case, you can look out for even numbers, which can be divided by 2, and multiples of 5, which will always end with a 0 or a 5. But ideally, what you want to do is to try to find the highest common factor. In other words, the biggest number that both the numerator and denominator can be divided by. And that's, of course, where your times table knowledge will come in. So I do hope you found this video useful, and please do have a look at my other videos on primary maths and SATS help. Thank you for watching.